Hey there, and welcome back to another Unreal 4 Shmup tutorial. So apologies if I've sounded a little bit more raspy than usual, feeling a little bit under the weather right now. And I just wanted to mention as well that I'm going to kind of draw some stuff back here, just in case I went a bit too fast in the past. I've had some comments about maybe not giving enough detail in some of the things I go over, so apologies if this is a bit slower for some of you, but I just want to make sure that everyone's up to speed. So what we'll be doing today is running through the player that we've already put into the level. At the moment we have the ship just flying up the screen and doing the introduction animation. And in the past we've came into the project settings, we've went into the input and we've bound our primary fire, secondary fire, move up and move right. So we'll be using some of these to drive the movement today. So to do this we'll go into the BP_player. And in here, what we have at the moment is our logic driving the animation. And I just wanted to recap, because this is really important, that when the spawn animation, so this is the logic, the graph which is actually driving the movement of the animation, we need to set the move enabled to be true on the finished node. So this will be the very last thing fired when this graph runs through its lifetime and reaches the endpoint here. We'll be getting the finished node execution. And if you don't do this, the player won't move. So just make sure that that is included. And then whilst this is running, we're just setting the location in the rotation of the player ship, which is the moving up the screen and rotating around the axis. So this was a bit of a quick introduction to rotation and locational offsets for the player, but we will be going more in depth and actually manually manipulating these anyway. So I was planning to leave most of the theoretical stuff to what we're about to be doing now. So if we move down the event graph a little bit. So what we'll be doing first of all is we'll be getting our move right and our move up input calls that we've made previously. So if we just type move up first of all, now what we see we get here is we get the axis value returned and an axis event. So I'm just going to add both of these to show you what they do. So this is the event returned and this is the axis returned. The only difference is this is what's called a pure function. So this is returning just the value, nothing else. We can't drive anything into this. We can't drive anything out of it. It has no execution pin. So the difference with the event is that this does provide the execution pin, which means we can drive future logic, which is what we'll be using because we need to set values and make things happen when this has been called. We'll also do the move right. And what I want is the axis event for the move right. And we'll just get rid of the value there. So quite simply, this is called all of the time, and the value will be updated when the player presses the relevant button, which will be either up, down, W or S, or left, right, A and D, depending on what you've mapped here. So if we do the move up first of all, what we want to do is set a value that we've already created. So we set all of these ahead of time. So when the player is pressing the up movement buttons, what we want to do is we're going to take this value and we will multiply this by another float. So float times float. And I'm just going to move it this way around to keep this tidy, although we're going to remove this a bit later anyway, so don't worry too much about this exact implementation. And we're going to times this by the movement speed. And what I've done there is I've control dragged the movement speed in, and if you just slot it onto one of the pins, it will automatically connect that for you. And remember that control drag is to get a value and alt drag is to set the value. Okay, so at the moment movement speed is empty, so click on the movement speed and I think a value of 2 works here. So this is going to be the speed that the actual ship will be moving at 2 units over time. And the next thing we want to do is we're going to set the vertical speed. So alt drag from vertical speed. And we want the returned value of this to be our vertical speed. And we'll just drag off of the input axis and we'll plug that execution node in there. So that's why we needed the execution pin. Okay, so we'll just do that same thing. So we'll just select those, press Ctrl W to copy those, drag this into the multiplication there, and we will just get, so alt drag in the horizontal speed, so this will control the sideways movement. Well, specifically, this will control the value for the sideways movement. What we'll be doing next is actually adding the movement. So we now have the values being updated. So whenever the buttons here are pressed, as I said, this value will be updated, which again, just to recall, is going to be between a value of 1 and -1, and 0 will be unpressed, and we'll be using that to drive the movement of the player. And this is a really, really simplistic implementation of it, and we'll be improving this. Possibly not in this video now. I've just noticed that it's already getting quite lengthy. So in the next video, we'll be making a smoother and nicer implementation of the movement. But I just wanted to make sure, as I said, that the basics are covered before just diving headfirst into adding and smoothing and stuff. So the next thing we want to do is we're going to move this down a little bit. We're going to get the event tick to come back in. So again, the event tick is another custom event or another function, essentially, which is called constantly. So this will be run so many times every second. So if we assume a standard of 60 frames per second, then this will be running 60 times every second. Another little trick is Unreal has some clever little help events that we can use here. So because this is what we have here are two returning nodes, we have the returning value and the returning execution. If we were to just click on the delta seconds, holding no other keys down, and just plug it into the value down here, it will know that the only thing that we can possibly do from here is to set a value. So it will give us a setter node, and it will plug the execution pin into that as well. So just a handy little time saver there. Now this is just going to be storing a value of the delta seconds into our own variable. And this is just because that we'll be using this in different places later. And rather than having loads of pins coming off of here and loads of different wires, which will start getting quite messy, we're just going to be able to call our own personal variable of delta seconds as and when we need it. So from here, the last thing we want to do is we'll pull off of the execution pin here and we'll type set actor location. And this is simply going to do what it says. It's going to set the actor location. The actor is this blueprint. And we're going to plug in what we need is the vector value here. So we're going to do a vector plus a vector. So that's our x, y, and z for the three different float values. We want to find the first argument is going to be our current location. So we're going to find the get actor location node. So we'll get the actor location. And then we'll just be adding an offset here based on the values that we've been tracking below, so the vertical and the horizontal speed. So we'll drag off of this pin and we will type make vector. So this is just simply making another vector 3 for us. And we then have control over the x, y, and the z components. So for the x component, so x is left to right, we want the horizontal speed. And for the z, which is up and down, we want the vertical speed. And this isn't too important right now, but what we do want to do is tick the sweep, which will be the collision detection we'll be using later for the bounding of the level. At the moment we don't have any bounding, so that's not overly important. But when we do add that in, obviously we're going to need that to sweep to detect when we could potentially be going through something whilst moving. And then if that sweep returns true, then we will be blocked or stopped. So that's going to be what stops us from going outside of the bounds. So if we compile that, at the moment this isn't going to work because we don't have anything set up. If we press play, we're not actually in control of the ship, we're in control of our default pawn. So if we press F8, we can eject out, we can find our default pawn, which is this strange grey sphere. It would be grey if we had a light, so if we pull in a directional light, we have this grey sphere. So that's what we're controlling. We're kind of flying around in that FPS freeform fly. Obviously what we want to control is our player ship, and you'll also see that we have a default camera being made as well. And this is all happening because in the project settings, under our maps and modes, we have given it a game mode, which is our game mode, but we haven't set the pawn to be our pawn. We have this as default pawn. So if we select this to be the BP_player, which is our player, that will be a step in the right direction. And even if we press play now, we'll still see that we get the default pawn spawned into the level. And we're still flying around in this weird sphere. And now the reason for that is because although we have a pawn in here, we haven't told it to use this. If we select our BP player and we go down here under the pawn section, we can see that the auto-possessed player is disabled, which means this is essentially just going to be considered as an object. Because we could drag loads of these in, it doesn't mean that we want to control all of them. We might just want to test how cool that looks to have 4 of them flying at the same time. So Unreal doesn't make these assumptions, we have to tell it to do something. So if we drop this down and select player 0. If we press play now and go in, we can see that we haven't got a default pawn spawned over here. And if we eject, we're actually inside of the BP_player. And that's because the obvious thing for Unreal to do now is to make us possess this player, but it still has to create a camera for us, so it puts that camera inside of the blueprint. So the next thing we're going to do is over here, you probably have the basic tab selected at the moment. Under the modes, we need to find a camera. So if we search for camera in the search bar, I'm going to grab the camera and we'll just put this anywhere in the world. Now go over to the location and put this on 0, 0, 0 for now, and give this a -90 rotation. I'm just going to drag this back a little bit. In fact, I'm just going to give this a value on the y-axis of 400, because I know that's going to put the ship roughly in the camera position that I want. And the final step, similar to the player, is that although we have this camera in the level, again, we can put in any number of cameras. So Unreal's not going to assume that this is the camera that we want to be possessing. So select the camera, we're going to go down, and under here we have auto activate for player. Just drop that down and select player 0. And again, because this is an array based thing, 0 is the first player, and because we only have one player at the moment, that's going to be the one we are concerned with. So if we press play now, we can see that we don't have the weird flying movement. If we press F8, we don't have our default pawn or the camera being spawned. This is the camera actor that we've added in now. And if we possess this, we have movement for our ship. And we can see that that is some really, really simplistic and horrible movement. And that is one of the things we're going to be fixing. As I said, I just wanted at the moment to get the theory behind what's happening and leave this quite simplistic so we can see what's going on without jumping too far ahead. So I'm going to leave this video here for now. It's already quite lengthy. As I said, don't worry too much about this because we will be making some major improvements to this in the next video. Likewise here as well. Hopefully that's all made a little bit more sense this time. The camera and the player we can keep in. And whilst we're doing this actually, I just wanted to mention one other thing. The option of adding a blueprint in and then selecting auto possess is one way to do this. The other way is we can drag in from over here a player start. And again, we'll zero this out. And the good thing about this is that if we add the player start to be player 0, again under the auto receive input, and hit play, what we should get when we press play is the player being spawned in, and we didn't. We get a default pawn, which just means that something over here has gone a bit funny. So if we go to the game mode, just double check that in our BP_game mode, we have all of these set correctly, which we do. Just end play mode, and so we've got BP there. So just compile to refresh and make sure this has happened. Sometimes this does happen, and there we go. So we just needed to refresh the blueprint, and it now knows that what we want to see is whenever there's a player start, the thing that it will spawn from that position is whatever we've defined in the default pawn class. So for some reason that wasn't driving through properly. Even though we had it in both places set correctly. It's just a good thing to know. I've heard that other people have had that problem in the past as well. So it's good to have had that happen on the video so I can show you how to debug that or how to correct it. So yeah, that's all we needed to do was just refresh the blueprint. It updated the data that the pawn that we wanted to see in the level was the BP_player. The engine then finds the player start and it will replace that with the blueprint you've told it to be the default pawn for the game mode. So this is actually going to be the way that we set this game up. You tend to find a lot more that this approach is used, having the player start in the level, because that adds the flexibility that if you have multiple different characters, and for instance you can choose that in a main menu system, you don't want to have had the ship manually placed or all of the characters manually placed and then delete them depending on which character's been chosen. What we can do is we can have a player start, and the game mode later can be passed the information of which character you're going to have. That will be changed here, and then the player start will be the component which manages that. So it's just a tidier approach, and it just makes the workflow a lot more dynamic. Okay, so we'll remove the player ship. That was there just so we could see the spinny thing. We're going to move that down a little bit. We'll worry about the placements a lot more when we're actually setting the level up. So this time I'm actually going to leave the video here. Hopefully that's been useful as always. If you have enjoyed the video, then please do leave a like and give the video a share. That really helps. If you wanted to find out when the latest content's coming out, then please do feel free to subscribe to the channel. Alternatively, you can follow me on Twitter. Links for that will be in the description below. And if you wanted to support the channel, then please do consider taking a look at the Patreon page. As ever though, thanks for watching, and I will see you next time.